All right, so this, we're still solving, we're graphing quadratic equations by factoring, okay? And I want to take a look here at number 8, because number 8 looks like a lot of fun. In fact, we'll do 7 and 8, but I'll start with 8 here. All right, so normally when we factor, we think, oh, we do the x factor chart, a times c, all that kind of stuff. But this one only has 2 terms, okay? So if I were to do this, okay, I would factor out an x and a negative, right? Because don't they have a negative and an x in common? So if I factored negative x out, I'm left with x plus 4. Okay, and that would be factored, right? I'm done. Great, let's set each part equal to 0. Okay, so negative x equals 0, and x plus 4 equals 0. Okay, we'll divide by negative 1. It's still going to be x equals 0. Okay. And if I subtract 4, x equals negative 4. Okay, so those are my 2 x-intercepts. It's 0 and negative 4. Cool. All right, now I need to find the axis of symmetry, which we know the axis of symmetry is negative b over 2a. X equals negative b over 2a. Okay, we know that b in the original equation is negative 4. So x equals negative 4 over 2 times negative 1. Okay, which is going to give me negative 4 is positive 4. 2 times negative 1 is negative 2. And so that's going to give me an answer of negative 2 as my axis of symmetry. Which makes sense, right? Because is my axis of symmetry always going to be perfectly in the middle of the x-intercepts? Yes, it will. All right, so if the axis of symmetry is 2, we've already found the x part of the vertex. Because the vertex will also always be in the middle of my graph because all parabolas are symmetrical. So my vertex, the x part is negative 2, but now I need to find the y part by plugging this in to the original equation. Here we go. So that's going to give me, here's where it gets a little tricky, so pay attention. So I'm going to have negative 2 squared minus 4 times negative 2. All right, here's where it gets tricky, because when I take negative 2 squared, a lot of students will say, oh, let's make those positive. But I can't do that yet, because that is a multiplication step. The order of operations tells me to do exponents before multiplication. So actually I have to do negative 2 squared first. That's the first part. So negative 2 squared is positive 4. Then I apply the negative to the 4, which makes it negative 4. A lot of students will make a mistake on that. Don't be one of them. We always do exponents first. Negative 4 times negative 2 is positive 8. And negative 4 plus 8 equals 4. So the y part of my vertex is at 4. So negative 2 comma 4 is up here. And then I just connect the dots. And again, this one's going down and out. Okay. And again, the last thing I want you to observe here for this graph is the vertex at the highest point or the lowest point of the graph. Well, it's actually at the highest point this time. So it's at the highest point, meaning it is at the maximum. Meaning it's the biggest or tallest or the biggest, the highest number that the graph can achieve is at the vertex. So the vertex is at the highest or the maximum. All right, so I hope these couple of walkthroughs give you an idea. Let's do number 7 and then we'll be done. All right, so for number 7, again, let's start by factoring. It's a trinomial, so let's go ahead and do the x factor chart. Negative 1 times negative 5 is positive 5. And then on the bottom I have negative 6. Two numbers that multiply to give me positive 5, but add to give me negative 6, are actually going to be negative 1 and negative 5, right? Negative 1 times negative 5 is positive 5, and then negative 1 plus negative 5 is negative 6. Okay, we have to actually work this one out because a is negative 1. If a was positive 1, we could take the shortcut. Okay, so I have negative x squared minus 1x minus 5x minus 5. Okay, let's group them together. We can factor out a negative 1 from the first, giving me x plus 1. Factor a negative 5 out of the second, or negative 1x, excuse me, from the first parenthesis. Factor out a negative 5, and I have x plus 1. Okay, so in my first parenthesis, I have negative 1x minus 5. In the second parenthesis, I have x plus 1. Set each part equal to 0. So negative 1x minus 5 equals 0. And x plus 1 equals 0. Okay. Add 5. Negative 1x equals 5. Divide by negative 1. X equals negative 5. And subtract 1. X equals negative 1. So those are my two answers, x equals negative 5 and x equals negative 1. All right. So those are my x-intercepts. Now I need to find the axis of symmetry, which, as we know, is going to be right in the middle of my graph, which should be negative 3, but let's do the math to verify. So it's going to be negative b, so negative negative 6, over 2 times negative 1. Negative negative 6 is positive 6. 2 times negative 1 is negative 2, so that's going to be negative 3. And that's what we should have gotten. All right, and not only is the axis of symmetry in the middle of my graph, so is the vertex, which that means I'm going to plug in negative 3 in for x in both spots. Okay, so because for my vertex, the x part is negative 3, but now we need to find the y part. All right, so I'm going to have negative 3 squared. We just talked about that pitfall earlier, so we're not going to make it because we do exponents first. Negative 3 squared is 9, and then negative times 9 is negative 9. And we do negative 6 times negative 3, which is positive 18, minus 5. Negative 9 plus 18 is 9. 9 minus 5 equals 4. So that means my vertex is at negative 3 comma 4, which is up here. And then we're going to just go bloop and bloop. And that's what my parabola looks like. And I notice that the vertex is up at the top, meaning it's at the maximum.